Hello all, welcome to my channel. In this video, we will be answering the question why current sources should never be left open. To understand that, you first need to have some knowledge on the internal resistance of a current source. Then we will see the effects when the current source is left open, and we'll try to compare the effects with that of a voltage source. And finally, we'll see what is the right way to design a circuit for a current source. So let's get started. A current source is a device which tries to maintain a constant current between its two terminals in an electronic circuit. A current source is represented by this symbol, and when it's connected to a load, it always tries to push a constant current I through the load. Irrespective of whatever the load is, the current will always be the same. That's the property of a current source. Now, for an ideal current source, the internal impedance Rs is infinite. But for a practical current source, it will be very large. This internal resistance Rs should not be thought of as in a lump component that is connected in parallel with the current source. It is the inherent property of the current source itself, and it will be distributed throughout the device. As now we understand the model of a current source, we can try to see what happens when the current source is left open. So this is the current source with a current I and the internal resistance Rs, which is typically very large. Now if there is no load connected between these two terminals, this current I has nowhere to go other than through this Rs. Since the Rs is large, the voltage developed across the two terminals V, which is given by I into Rs, V will be very large. That is very evident because Rs is large, and the current through Rs is always a constant. Suppose, assume that you have kept the current source open for a long time, and it has developed a large voltage across its terminal, and if some person tries to handle this current source, it can be quite dangerous. Now let's try to put this in a circuit and understand what is its effect on a load. So the usual way that most of the people think to connect a source to a load is through this circuit. We have a current source I, internal resistance Rs, we have a load. This can be any circuit, and a switch. When we want to energize this load, we will close the switch and the current I flows through this load. That is what most of us see, but as from our previous discussion, if the switch is left open before connected to the load, the voltage across the current source V will be very large, and as soon as you close the switch, the large voltage V will appear across the load, and this voltage can damage the device. Most of us are familiar with voltage sources, and as we know, The internal resistance of an voltage source, of an ideal voltage source, is 0, and that of a practical voltage source is usually very small. And if we try to short circuit the voltage source, a large current I will flow through this short circuit, causing a large power dissipation in RS. This will lead to the battery heating up, and also the charge in the battery will be drained out. So how are these batteries sold in the market? If you buy a AA battery, it is always sold without the two terminals being connected together. That means the battery is sold as an open circuit device, and that is how voltage sources have to be stored. Therefore, a voltage source is always kept open when it is not used, and the voltage across the terminals will be V, and the current through the voltage source I will be 0. Therefore, there will be no power dissipation. Similarly, for a current source, the right way to store it is by short circuiting this terminal. This way, a constant current I always flows to the short circuit terminal. There will be no power dissipation in the resistance RS, and the voltage across the terminals of the current source V will be 0. So let's try to redraw the circuit that we previously had. This time, instead of putting the switch in series with the load, we will keep the switch in parallel with the load. When you don't want to energize the load, the switch is kept closed, and the current I will flow through the closed circuit, and the voltage across the load will be 0, keeping the device safe. And now when you want to energize the device, you just open the switch, and the current I will start flowing through the load, and the voltage developed across the load will be proportional to the impedance of the load. To summarize, current sources, when left open, will develop a large voltage across its terminals. The right way to store a current source is by short circuiting its terminals. Therefore, in a circuit, if a current source is used, the switch should always be placed in parallel with the current source. That's all for this video. Thank you.